Welcome to 60 Minutes On, from theory to project practice. This webinar is organized by the Clean Energy Transition Partnership. The webinar series will hopefully help project proposers and project managers to implement their solutions according to the most advanced and international recognized practices for a maximum impact of their projects. Welcome to 60 Minutes on Interoperability, from theory to project practice. This webinar is organized by the Clean Energy Transition Partnership Transition Initiative number 1 on integrated energy systems. Now, what are integrated energy systems? These systems are the systems where disciplinary silos between electricity, heating and cooling, water, gas, and data are abated. These are systems where each energy sector and energy vector contributes to the development and working of the entire energy system in a seamless and efficient way. Essential keywords of the integrated energy systems are flexibility, conversion, and digitalization. Flexibility, because all means to foster and balance the use of renewables to feed the energy system must be adopted. This is to ensure supply also when the sun is not shining or when wind is not blowing. This can be achieved inside each of the energy networks by, for example, energy storage, or by connecting different carriers through conversion systems. Power to heat, power to gas, gas to heat, etc. The overall system will work adequately only if a wide digitalization is efficiently implemented. And this is the theme of our webinar: how to adequately implement the digitalization in the energy system. The scheme of the webinar is organized into 2 sessions. In the first session, a world-known expert will describe and discuss the theory behind the subject of the day. In our case, interoperability. In the second session, we will look at possible applications of the theory into a project practice. This will hopefully help project proposers and project managers to implement their solutions according to the most advanced and internationally recognized practices for a maximum impact of the project. Let us start with our webinar on interoperability. Our first speaker is Professor Antonello Monti. He is, among many other functions, professor at RWTH University in Germany. Antonello, the floor is yours.
Good morning. My name is Antonello Monti, and today I will talk about the changing role of interoperability. In the next few minutes, I will discuss how the concept of interoperability is evolving while the energy transition is happening and is bringing us new challenges. Few words about myself. I'm a professor at RWTH Austrian University, where I'm also director of the Institute for Automation of Complex Power System. Jointly, I'm a group leader at Fraunhofer FIT, the Center for Digital Energy, and currently a coordinator of several large European projects. I would like to mention here INTNET, which exactly focuses on interoperability, but also One Net Platone, which are 2 projects that I will refer to also during my presentation. So what is interoperability? Let's start with the definition. Interoperability refers to the capability of a system or a component to work with another system or component. This is a very broad definition that came mostly from the information technology area, but now, because of the mix of IT and energy that we see in the modern power systems, we have to ask, what does it mean for modern power systems? And how do we guarantee interoperability? And how do we verify interoperability? This will be, answering these three questions will be the main content of my presentation. And let me start with, let me say, an overlook on what was the original situation about interoperability. If you ask electrical engineers if you could have the chance to ask a few years ago, you would have thought interoperability as a rather simple idea. Because interoperability in the perspective of an electrical engineer was basically how do you connect things, and basically once you define voltage level and few other parameters, interoperability was an easy task. But with the impact of digitalization, then the concept of interoperability is definitely evolving, and we need to cover way more aspects than what we used to be. Interesting element in this direction can be perceived by the smart grid architectural model, so the so-called SGAM, because here we start talking about different layers, and all these layers are the different levels at which the interoperability should happen. This architecture being also at the focus of a report of the ETIPSnet a few years ago on digitalization, in which the description has been a little bit simplified, and at the end we can say there is a physical layer related to interoperability, which more or less is the, let me say, old idea of interoperability. Then we have the infrastructure layers, which deal with all the elements connected to the operation of the infrastructure, so how the grid runs and all the related automation and so on. And then on top, we have a business layer. So what are the economic reasons driving? So what are the use cases that are driving, and then services that are connected? Why is this becoming relevant? But there are several legislations that are driving the process and creating the need for this digitalization. But we have to understand that this is a change in a change, because digitalization comes with decarbonization, and that's where the challenges are getting a little bit more complicated than in other sectors. So digitalization is happening basically everywhere, but in the energy is a little bit more complex. And what is interesting is that it brings not only technical but also social challenges, because behind the whole system there is a fundamental change on what are the actors and the players in the system and how they can interact. And then we look at what are some ingredients that can make this possible. And when we talk interoperability, we'll see that when it comes to digital systems, a very relevant topic is data models. And I will comment more on that with a few details. And here I will say electrical engineers have been active in this field for quite some time. So they're a very good starting point, at least when we stay strictly considering energy equal electrical energy. Then we need architectures. So data have to operate together. And here there are a lot of activities going on, but still we don't have a global concept of interoperability in which all the architectures can work with each other. We need business models to motivate. And also here there are ideas, but not really a killing application that is the one driving, even if there are some use cases that, for example, the European Commission identified as more critical and relevant, like immobility or demand response. We need governance, because one of the other challenges we have, the more data are involved, then we have a lot of issues related to who owns and how we can use the data. And here there's still a lot of work to be done. But like I sort of already say indirectly, we also need to make sure the data can travel across different energy carriers, because the transition may happen only if the electricity is linked to other infrastructure. And that's, again, a region where a lot of work is needed. A lot of research is going on in this field, and oversimplifying the electricity system as a three-layer infrastructure where we have customer, distribution system operator, and transmission system operator. So going from top to down, the large national grid, the local grids, and the people. We need to understand the data exchange among those players so that they can be with each other interoperable. And there are several initiatives that is worth mentioning, because several research projects have been already tackling some of the fundamental challenges here. And we'll say that at the NTSO level, so transmission, the single entity has been driving a unified approach in Europe, which is one of the key strengths of our infrastructure, because all the TSOs work with the same rules and the same approaches. We have a lot of significant projects for the interaction among the levels. And for the interaction, we had some relevant projects that ended last year called Interface and Coordinate that looked at what are the needs and the options for those interchange between different layers. So first steps in direction of interoperability. We have some project targeting specifically to achieve the same coherence at the DSO level as we already have at the TSO here. I can mention Project Platone that I will mention also later, that focuses more on the operational part, and Project Universal that is more focusing on the market aspects related to interoperability. And at the customer level, the Project Interconnect is standardizing a lot of data exchange and data representation to make the things possible. Another initiative that is bringing all these things together is the OneNet project, which is trying to create a common picture among this, so creating very important input for a serious interoperability process in the overall Europe. But when we talk interoperability, the challenge, as I say, we're being really good already, at least the interoperability of data, particularly in the electrical engineering domain. There are international standards coming from IEC, for example, like the Common Information Model, which really allows us to have a good level and easy process for interoperability. But this is complete, but only, quite well developed, also only, in the electrical domain. We need data exchange. Here, we need more activities because we need to define rules and process for the data exchange. And even more challenging is the interoperability of service. Going back to the previous representation of the layer was GAM, these last layers were exactly the business layer, maps, and the data exchange is more related to the intermediate layer that I showed you before. Some important element when we talk about data exchange, particularly because customers are involved, data sovereignty and privacy are a key element that we have to put into the context when we do studies and application of interoperability. Here, a lot of background work has been done in other sectors, so the relation to the Industry 4.0. The International Data Space Association has set some reference solutions that can be and are currently expanded in some of the research projects, like, for example, the OneNet project, to support the energy use cases. And then the problem of going across domain, so building solutions that are not strictly electrical. Here, some reference solutions are given by the open API of the FireWare architecture. But we need some further development, and there are some key ingredients that are relevant to make the process possible. One is the concept of ontology. So data model deals only with giving a meaning to data. Vice versa, you may say the ontology brings also the problem of interrelation among data. So it's a little bit more complex idea. And the idea is also that through the process of ontology definition, we can overcome the limitation of single data models, so solutions that work in a small part of the sectors while we build an overarching, as I say, for example, going beyond electricity. Here, I'd like to mention some research work that has been published on developing an ontology that brings together some of the key ontologies and data models already available, like the 61 and 50 from IEC or the Common Information Models, but also other relevant, more related to the building sectors and the customer level, like SAREF, and creating a common picture for data. But what is challenging is that normally this needs to be adapted and evolved, so it is also critical that we build solutions that are ready for inclusion, so that can evolve, learn, and incorporate data from different sources. Because we don't know today how the structure will be at the end. We are in a process of change, and we need to be open and flexible that solutions can learn, adapt, and evolve with time. So for that, I mentioned here a tool that has been recently released called CZEG for the automatic processing of data and inclusion in ontologies that can live together with the Sargon concept I showed you before. It makes an overarching system that allows data from different sources to become data we can manage and then are interoperable and then are allocated within an ontology, so there is a full structure for data management. Other key ingredients, and that goes back to what I said about the International Data Space Association, are data connectors, because it's critical to, in the interoperability process, to keep into account the problem of data sovereignties. We need metadata infrastructure that, while we preserve the interoperability of the meaning of the data, which is what we address with ontology, allows also to transfer the information about data sovereignty. So who and how and when can access the data. These have been seriously addressed in the OneNet project with the purpose to build an architecture that allows platforms from different grid operators to exchange data while preserving control on the data. So the so-called OneNet connector, which you see here represented as an architecture, is an evolution of the connector developed by the IDSA, and incorporating also component of the fiber architecture to go into the openness and flexibility of data management of the fiber architecture, so that while we exchange data that can come from whatever data provider into a European-wide energy system, we preserve not only the meaning and of the information, but we also bring together the information related to data sovereignty. All this is showing that in the digitalization, we are actually trying to change the process through which we reach interoperability. Because standard path was, in any technology, there is a research and development phase, then industry work together to find agreement and define standards, and then we have the market application. This process is perfect, let's say, but rather slow. So what we experience more and more, that we build solutions starting from open communities, maybe coming from project and research project, and the process starts in parallel. So the standards are more and more becoming results of the work of communities that pre-agree on standards and then move to the official body standards that we still need, but at the same time the market can start early enough, not waiting for the standard to be fully developed before things can get to a mature market. So all in all, what I'm trying to say here is that we have a faster path to interoperability from research to market. We still need standards because at the end this set the reference on what is accepted, but the process standard is now working in interactive ways with open communities, and that's what is bringing the openness in the process development as another key ingredient of interoperability, which links to open data and also open source software as new tools we have to accelerate the process, which is critical for the energy transition. So we need sharing data. This is true for research and business. So we need more and more research data and infrastructure. We need data space to facilitate data sharing at the business level, but we need that process in software. Building community for research that support structural development, but also open source for business, but open source with governance. And here are some solutions that are happening. So for research data infrastructure in Germany, we have a large initiative called National Research Data Infrastructure, so Nationale Forschungsdateninfrastruktur in German, which is building this solution in Germany using international standards so that it can be easily replicated in Europe. At European level, we also have the project ERIGRID 2, which is helping to create a European infrastructure for research and then data exchange. We have the initiatives on data spaces, which are moving extremely fast. Key standard we can use to start reference implementation, and a coordination action that we'll present later called Internet, which is supporting a unified picture for data space development. We need joint structure development. I will give you a brief example with a new association called CRESIM, which is achieving that in the power system modeling. And we need code development, open source with governance. And here the Linux Foundation Energy can be a good example. But what we mean by open source, this is very important because open source, there are a lot of misconception that I summarize here in the slide as low quality, not trustable software. And when we say that we need open source to facilitate the process, I'm not referring to any of this, but referring to a software developed by community with shared effort, with clear rules of governance, and with validated process security. Software with open source is actually more secure than the one developed as closed process, if and only if use the highest industrial standard in relevant association. It doesn't mean that it's in competition, but it supports proprietary solutions, so a good combination is critical to build the interoperability, and allows to avoid vendor lock-in, so that's an advantage for the customers, and it brings at the end for everybody a big cost reduction because of shared development. These are the key elements that make open source critical also for interoperability. And this is what the Linux Foundation Energy is driving. And it's important to say this happened already in other sectors. This is a normal process. You see here that in other sectors, we are coming out to something between 70 and 80% of code that comes from open source library. Same should happen in our sector. And many companies are buying into this. So this is becoming a bigger initiative that is aligning everybody and then giving automatically interoperability. And a lot of projects, so basically covering with open source all many, at least, aspects of the future energy system. Same should happen in research. A recent initiative is the creation of an association called CRESIM, where industry is putting money together to build open source solution for basically modeling and of power systems. This is another critical initiative, and again with the same philosophy that build interoperability from the starting point, not as a result at the end of the process, but as a condition from which we start. And this you can see here support already from some large transmission system operator, but is an expanding initiative that hopefully will cover more and more operators also at distribution level. But to coordinate all this, as I mentioned, a current ongoing project is called Internet, Interoperability Networks. And here in this coordination support action, we are trying to bring all those ingredients together and developing a framework for interoperability, an interoperability maturity model, but also process for interoperability testing. And around that, we need a community that will survive beyond the project so that all the lessons we learn, everything that I told you so far, can be sustainable in the long term. And so the outcome we expect to have is, first of all, to store and make knowledge available. Everything I told you must become public knowledge, tool to assess and increase the maturity model so that we have a way to evolve in the interoperability process, and a network of labs that can support testing to guarantee the interoperability. Yeah, at the end, the project will deliver a community network and make sure that this community will preserve the results in the long term, for also in relation to key initiatives like data space and digital twin. The contribution will be in two directions: governance for interoperability and testing for interoperability. So how do we organize ourselves, and then how we openly can verify that what we produce is actually interoperable. Just completing some projects where these solutions have been working in the Platone project, thanks to starting from open solutions, the grid operator Rome, in alliance with the project and the Linux Foundation Energy, developed a solution that used standard interoperable architectures and standard data process to transform the DMS, the distribution management system of the greater Rome, and at the same time opening with this process a first real implementation in large scale of a flexibility market. And this is a key asset that allows customers to be integrated in a standard way in a large electrical grid. Second example is the OneNet project I mentioned before, where the connector being developed, and this is tested already and implemented in a huge list of grid operator in Europe, so that again, starting from agreement we do at the first level with open solution, the path to standard becomes way faster than what used to be. With this example, I would like to close my talk and thank you for your attention.
Thank you very much, Antonello. You have unveiled the importance of digitalization in the development of energy systems. You have also defined for us the concept of interoperability, highlighting the role of data, its meaning, its grammar, its semantics, as well as its risks in terms of data privacy and cybersecurity. You have highlighted the importance of the use of open protocols to ensure transparency and avoid vendors locking. Finally, you have opened the doors on standards, from industrial de facto standards to official and adopted standards, and on the possible ways to ensure interoperability and to test it practically. And this opens the way to our second speaker, Angela Berger from Austria. She has studied interoperability in great detail, starting from the health sector, and has successfully transferred her wide experience to the energy sector. Angela, thank you very much for joining us, and the floor is yours.
I welcome you to my presentation for the TRI webinar for interoperability. My name is Angela Berger. I'm from Austria, where there's a lot of experience with interoperability in the healthcare sector. For about 8 years, I've been one of the drivers to promote the knowledge transfer from their good experience in healthcare into other sectors like the energy sector. In the next minutes, I will introduce you a process chain to achieve interoperability in digitalization and how to carry out interoperability tests. First, I will talk about communication infrastructure. Then I will introduce you to the process chain for interoperability, and I can offer you an example for a practical implementation of the process chain. Then we are ready to talk about interoperability testing. Interoperability is a matter of data model, communication infrastructure, and a governance that sets the rules for data usage. So what are the necessary requirements for the data communication in digitalization? We have our actors and market participants. The established ones and new participants will appear in the future. Today, they all collect their own data, but due to the missing interoperability, there's not very much communication among them, and they all do optimization for their own business. In an integrated energy system, all participants have to be connected. The question is, how could this be done in an efficient way? The first approaches were central data hubs. The idea was that everyone should store their data in a central data platform, and new business models can collect the necessary data from the central data hub. It looked as a cheap and easy solution at first glance. But that means to give up data sovereignty of your own data. The moment you store it to an exchange platform without a defined governance, you cannot be sure what happens to your data. Therefore, this option is not possible for critical infrastructure. We have to find another way for data exchange. Another approach is to keep the data decentralized at their owner and make a joint communication infrastructure, which ensures identification, authorization, and security, like encryption, as a part of a common governance. Using this infrastructure, actors can define together use cases that implement them and implement them with normative interfaces, where you only receive a defined set of data for a specific use case. Additionally, the joint communication infrastructure can enable cross-sector and cross-border data exchange. As a conclusion, what does this mean to innovation? The functionalities of the ICT systems are innovative, the interfaces have to be normative, and the seamless data exchange accelerates new business models and solutions. To be successful, interoperability must be a European issue. All current European efforts are based on the European Interoperability Framework, where they define 4 levels of interoperability. The first is the legal layer, which describes the legal framework for a specific topic, such as use case. Then there is the organizational layer, which defines the business processes for a use case. For example, when do I get the data? What happens if the data doesn't come or is wrong? All the possible cases have to be considered. The semantic layer means, do we speak the same language? For example, do we expect the same data units? At last, there are technical issues. Here we talk about standards and technology. I admit, when I was starting my work for interoperability, I thought the topic of all was about data models and the normative use of existing standards. I had to learn more about it. However, for digitalization, we also have to harmonize the underlying processes, which means to follow the 4 layers. When we want to achieve interoperability covering the 4 layers mentioned before, we have to include many stakeholders. This seems to be rather complex. But the positive message is there exists already proven experience to build on. In this context, we see healthcare industry as a pioneer in the field of normative use of standards. There, the IHE was founded because of the problem the healthcare products from different vendors didn't work together, although they used the same technical standard. The Horizon community has developed their governance, which was formalized in a technical regulation at ISO. At first, we started the project IES in the energy sector, which made the first cross-sector knowledge transfer and the adaptation of the IHE methodology. We made the proof of concept for the methodology transfer and the usage of the testing platform and tools in the energy sector. Last year, we had a project IRS in the railway sector, since the methodology of the IEH is in its core sector neutral and therefore applicable for any sector and digitalization issue. With this slide, I just want to show you that from the beginning, we saw the work for interoperability as a European and international issue. In the project IES, we adopted the IEH approach and defined the entire process chain into 3 pillars. Pillar profile. Users and vendors jointly specify use cases and the corresponding data exchange. According to the 4 layers of interoperability, this is done in as much detail as necessary to achieve a normative specification of the interfaces of the corresponding ICT systems. Several use cases that belong to a specific domain are combined in a technical framework, which is the result of the specification process, which is the first pillar. Once the technical framework is released, vendors can use it for the implementation of the interfaces of the ICT systems. The pillar test. Software must be tested to provide interoperability. The tests in this approach are peer-to-peer tests between the ICT systems. You can also test prototypes, since only the communication between the interfaces is tested and not the functionality. In an established organization like in the IHE, there are Connectathon test events which last more than 1 week, a whole week. Testing is a very important part of the work and real hard work. The pillar adoption. To run these processes, the goal is to have a community that is process owner and publishes the relevant information such as technical frameworks and test results. And there's the governance. An organization needs to have rules for their cooperation, responsibilities and decisions. They have to define who can take part in the boards and committees or organizes the test events. Also part of the governance is the entire specification and testing process. described in 3 pillars. Remember, the methodology is formalized in the ISO technical report. In the project IRS, we defined the whole process sector neutral in a white paper. And at the moment, we talk with IEEE to define a standard for a model process for interoperability. Now I come to my example. Now I want to show you the linkage of the 4 layers of interoperability and the IES process for a specific example coming from Austria. The example is in the domain of energy communities and describes how an energy community can get the consumption data from the network operator according to the Austrian legal framework. In Austria, the legal authority e-control determines who has the responsibility for defining the establishment of the data exchange with all network operators. This guideline is one part of the legal framework, and there is the legal layer. The individual necessary processes themselves are defined by EB Utilities, which is organized by the Austrian energy industry. This is corresponding to the operational layer. EB Utility also specifies the XML scheme for the data exchange. This belongs to the semantic layer. And finally, for the implementation of ICT systems, there are the technical issues like the existing standards. Even though it seems that the existing framework and public documentation provides already everything you need for the implementation, the experience showed that implementers have not enough guidance for their work. Remember, we need interoperability among the different vendors, and if there's room for the interpretation of the implementation, we don't achieve it. In this case, the IES process can start with the available information, identifies the gaps for implementation, and provide a structured approach to extend the existing documentation. The result is a technical framework for energy communities. In the ERANET project Sonder, we specified the technical framework for digital interface for energy communities. For that, we invited implementers from other projects and from companies who intend to implement commercial software solutions for energy communities. Using the experience of the participants in implementing the EB utility processes, we specified the first integration profiles for the exchange of consumption data. Based on the table of contents, I give you a brief overview how to find the necessary information in the technical framework. At first, there is an introduction to the technical framework. That means how to work with it. For instance, you will always find a Volume 1 and a Volume 2, which both have a specific structure. Volume 1 contains the informative description of the technical solution, which is more than only the interface description. Chapter 1 is the domain overview. Here you find everything you have to know about energy communities and their communication with the network operators. Here you find a reference to EB utilities and a connection to the communication infrastructure. This covers the legal layer. Chapter 2 are the use cases, which is the informative description of what happens and who is involved in the use case. In this example, it's the energy community and the network operator, which is in charge of the metadata infrastructure in Austria. The chapter contains the textual description, an overview of the steps in the use case diagram, and a description of the actors involved. But at this time, we don't talk about technical systems yet. In Chapter 3, the integration profiles are described, which is already a more technical description. The integration profiles describe the data exchanges in transactions. The actor transaction diagram specifies the ICT systems which exchange the data and each transaction of the use case. Such a transaction can cover more than a single data transfer. Here, experience and knowledge about the granularity of the specified transactions is very important. This has an impact for the testing later on. Otherwise, not all process steps can be tested correctly. The information flow diagram shows more details about each transaction. These chapters cover the operational layer. Summing up, in Volume 1, you will find everything to understand what happens in this use case and which ICT systems are involved. Then Volume 2 contains the normative specification of all necessary transactions. There, the implementers will find in Volume 2 all they need for their actual work. Every transaction has a normative description of the individual data transfers for the use cases. You see, there's a lot of necessary specification for each step in the transaction. Volume 2 covers the technical layer. Today, XML schemes are often already defined, like in our example from Austria. They can be attached in an appendix, which then covers the semantic layer. Now you can see that this structured document covers everything we need to implement interoperable software interfaces. The structured approach is important to ensure sufficient specification. The proposed document is intended to guide the process, but it can be understood as a working proposal. If a community has a similar way to achieve the necessary outcome, it is of equal value. But we recommend keeping this structure, as it allows us to be in line with the healthcare system and therefore leverage synergies in reusing existing profiles, for instance. In addition, the preparation of the test platform GAZELLE is also realized via this structure. So far, we talked already much about the specification process. Now we will have a look to how to test the implementations. The technical framework is not only the normative specification of the implementation, but it also serves as the basis for the test cases and the validation tools. These are parts of the GAZELLE test platform, developed for the healthcare sector and has been expanded in the IES project for the interoperability testing in the energy sector. The interoperability testing is carried out as a peer-to-peer test between two ICT systems and a test platform in between. The test platform GAZELLE offers a test management, validation tools, logging of the messages, and so on. It is possible to test for the conformity to the used standard and for the interoperability of the two systems under test. At a Connectathon, you run the same test multiple times with different partners. If you couldn't prove that, we wouldn't have interoperability. Here you see just some examples of the GAZELLE test steps. On top, you see the detail from a test management system. Below of that, you see on the left side a specification of a transaction and its test steps out of the technical framework. In the energy sector, standards are used which send binary messages. To be able to test such messages as well, we expanded the GAZELLE test platform to transform the messages in another format for the test validation. Transformed messages or XML schemes then get validated, and the test system generates a report for of the validation results. This picture shows the IES Connectathon, which we organized at the end of our project. We have published a technical framework with exemplary use cases for virtual power plants using specific standards. And we invited companies and other interested projects for interoperability testing to the IES Connectathon. Attendees who were not involved in our project showed with their participation that they could implement the interfaces only based on the usage of the technical framework. And you see very concentrated phases. Even it was only about testing exemplary test cases. At a Connectathon, you can fix software bugs. The goal is that in the end, the seamless data exchange. The other picture shows a Connectathon in an established process in the healthcare sector, where hundreds of implementers test their software. Even competitors work together because the goal is that all of them can finish the tests. Interoperability is only proven when you can exchange data with more than one partner, so testing is a collaborative effort. The successful testing is also the end of our journey to interoperability and digitalization. I hope I could give you an impression about practical approach how to achieve interoperable solutions. The presented methodology is ready for use. But still, a lot of work has to be done for seamless interconnected energy systems. So I hope I could give you an impression that the key for the interaction in a connected energy system is interoperability, and that this is more than just using a specific technical standard. I invite you to take part in an active community for interoperability, which of course has yet to be built in the energy sector. Therefore, I say thank you for your attention, and I hope I will meet you again in a European interoperability community.
Thank you very much, Angela, for your excellent contribution. Starting from the absolute necessity that actors in the energy systems have to exchange data, you have described the centralized and distributed approaches. You have given us the insight about the 4 layers of interoperability, that is technical, semantic, organization, and legal. You have unveiled the role of the stakeholders, starting from your experience in the health field to drive us to the energy field. And you have driven us through the process chain to achieve interoperability with special reference to its 3 pillars: profile, test, and adoption. Interestingly, for our projects, you have illustrated example of application of the concepts to the real energy system project, dealing with energy communities in Austria. To remain in the practitioner's domain, your speech has illustrated the technical framework for interoperability, ranging from a structured information of technical system to normative specification of transaction. And finally, you have proven the real applicability of the entire process into a real and practical exercise of interoperability testing, the so-called Connectathons. I really hope these 2 sessions were clear and useful for our audience. The entire material, recording and slides of the webinar are going to be available from the Clean Energy Transition Partnership website. Should you have any question, please address them to us at TRI1@setpartnership.eu. The TRI leads and the experts will be very happy to answer all your doubts and receive your suggestions. Looking forward to seeing you again in a future webinar of 60 minutes on From Theory to Project Practice of the Clean Energy Transition Partnership. I greet you sincerely and wish you all the best in your work. Goodbye.